Okay, we're going to start looking and really just doing an overview on our first session here of module number 7, which is going to be our learning plan for our gearbox design overview. So in module 7, you're going to notice that there's a bunch of stuff in here. This is where we're going to bring together things that we've been talking about up to this point into one design project. So you're going to be the designer. We're all going to be working on the same type of project, but everybody's going to have different gearbox specs, and we'll do that next week. But to prepare you for that process, what I want to do is I want to kind of introduce you to what we're going to be doing, and that's going to be in the learning plan and gearbox project overview. So as we look here, you're going to notice at session number 1, I'm going to be assigning to you to read chapter 15, and we'll look at that briefly today. But this is going to be going through the process of the completion of a design of a power transmission or a gearbox, okay? So through that chapter, you're going to see kind of the progression of the things that have to happen in order to get through that whole process. Then what you're going to do is I'm going to assign that you take a quiz on chapter 15. And it's just a multiple choice, true, false quiz to make sure that you went through and you kind of picked up the things I needed you to in that chapter. And then I also have for you here is for you to watch this YouTube video, and it's just how reduction drive works. So it's kind of, you know, in case you don't have experience with that, it's a really nice, like looking at the inner portions on how the gears work together to create a gearbox. Okay. So, and that's, I think it's like 10 minutes long. All right. Not very long at all. I need you to have these things done before our second session, which is going to be next week, Tuesday, when we meet again the next time. Okay. At that time, we're going to be looking at the next items here. We're going to be putting together a project task list. We're going to be brainstorming based on the fact that you've gone through and you understand the material that's in chapter 15. Now you're going to be telling me, what do you think, you know, the things are that you're going to be encountering and having to do to get through what we're going to be designing as a double reduction gearbox. So it's going to be slightly different. We'll look at that in a bit. You're also going to be getting some specifications. So this PDF has the specifications in, as well as your own unique RPM, horsepower rating, and train value for your gearbox. Again, everybody's going to go through the same process, but you're all going to have different values, right? And then you're gonna be making this task list for me. We're going to be talking about resources that you're going to need for each thing and just kind of organizing that. It's kind of like a project kickoff, if you would. And then additionally, the next time we meet, we're going to be talking about gear design overview, and then also what you need to add into a gearbox or a gearbox layout that you're going to be creating. So, so that's what we're going to be doing the next time we're together. Next week, a week from today, which would be next week, Thursday, we'll be revisiting shaft design and how it's going to be used in our gearbox, as well as bearing design. And then the following week, sessions 4 and 5 are going to be on key design, locational elements, and then also putting together what I'm going to call our project portfolio. Now, right now, this is my best guess at how we're going to be doing things. If it feels like we've got plenty of time to kind of move ahead, I might pull key design up in session number 3 or shaft design up in session number 2. We'll just kind of play that by ear. But right now, I'm anticipating it's going to take us about 4 to 5 sessions to get through this design. So, so let's open up and look at chapter 15 so that you get an idea of where we're starting and what we're going to be doing. So chapter 15 starts on page 589, okay? And the title of it is The Completion of the Design of a Power Transmission. The chapters that we've looked at, including gear design, shaft design, keys, and bearings, have all been separate elements that we've looked at in terms of like different examples and cases. But now what you're going to do is you're going to be taking gears, shafts, keys, and bearings, and we're going to be putting them into, you know, one design. Now, if we look at, and I'm going to skip over to page 593, they show a nice kind of transparent-ish pictorial of a single reduction gearbox. Okay, single reduction gearbox. This would be like the pictorial of it, kind of looking inside. And then down here is going to be, you know, kind of that like side view, if you would. In a single reduction gearbox, we're just getting one input. There's going to be a pinion on a shaft, and then we're going to have an output gear, and then it's going to send it to an output shaft. So there's only 2 gears in here. That's only one reduction, meaning we only have one velocity ratio that we're doing in there. In our case, we're going to expand on this a little bit. We're going to make it a little bit bigger. Okay, we're going to get more practice. So we're going to do a double reduction gearbox, which means that we're going to have an input and output, but then on this shaft, we're going to have another pinion to another output. So there's going to be a first reduction and a second reduction, or a first velocity ratio and a second velocity ratio. So our gearbox physically gets a little bit bigger, and there's going to be a couple more parts on it. But the process that you're going to go through is exactly the same as a single reduction. Just we have a couple more parts to it. Now, the parts that we are going to design are only going to be, I'm going to call it the guts, okay? It's going to be the gears, the keys, the bearings, and the shafts. We are not going to be designing the housing around it. We're not going to be designing bearing retainers, okay? We're not going to be designing and looking at coupling it with anything else. We only have enough time to focus on those elements that we've looked at to this point. So we're just looking at those inners, if you would, okay? And you're going to be determining, okay, what is going to be the size of the gears? What is going to be the size of the shafts, those minimum shaft diameters, then making them fit with the gears? What are going to be the key sizes? What are going to be some tolerances that we're going to have to apply to that? We're going to be visiting that and showing how to do that. And then also making sure that we have bearings that are going to, work for the application that we have, okay? So that's the project that we have coming up. Now, like I said, everybody's going to go through the same process. Everybody's going to have their own design. So you're working, if you would, independently, but you're all going to be going through the same process. So what I think would be nice is if everybody, or as many people as possible, come to campus, so that not that you have to work in pairs or work in teams, but let's say you're bouncing off an idea and you got stuck in one place. How did you do this? Or and how does somebody else, you're a little bit further. How did you devise that? And I think that's very valuable, because that's going to mimic how you're going to be expected to work out in industry, is kind of work with your peers and work through things. Okay. Now, as you look at this chapter, it's not terribly long, but like I said, it goes through and it lays out the process. First is gear design. Then they look at shafts. Then they look at bearings. Then they look at keys through this whole process, okay? Now there's tables and things that they're referencing here. So there is some, if you would, white space, but it's not a bad read. This is one of the very few textbooks that you're going to come upon here in the mechanical design program, in an engineering, type of program in general, where the book is actually enjoyable to read and it makes kind of sense, because usually engineers are not writers. Okay. So you're going to notice, you're going to go through the process. They're going to show you some examples of shaft drawings. And then they also have this assembly drawing that they created as well at the end. Okay. We are not going to be creating drawings. Unfortunately, we don't have time to do that. Okay. So kind of like the before, right before you're going to really kind of put the sides on the box before you're going to make the drawings. We're just designing those elements that we've been seeing up to this point, which is enough. Yes. We are not doing anything in Creo. We are just doing the design work. Like, we're going to pick out the gears and we're going to pick out the shafts and we're going to do, the things that we have been. If you wanted to create any layouts or anything like that using Creo, you may, but you don't have to. It can all be done in a 2D sense, whether it's AutoCAD or even scaled sketches. I don't mind if you do that as well, because we're on like that front end of the design process, if you would. But if you find that using Creo or other CAD, not required, is going to be helpful for you, then you may. All right. And then we'll also talk about the process and the portfolio and such. Okay. So you're going to notice that, for instance, on the shaft here, when they've got their bearings called out, they're just using an Excel spreadsheet to catalog, if you would, what are the tolerances that I'm going to put on my shaft so that I can see what the fit is going to be. Okay, so that's really as far as I want you to go with tolerancing. Does that make sense? You don't need to put it on the drawing. Would I like you to do that? Yeah. If we had a couple more weeks in the class, yes. But this is going to demonstrate that you know how to use vendor catalogs, identify and pick out and size the different elements that are in here. And then that way you get that experience of going through a project similar to this. Okay. So that's what you're going to do. So the first things first, you want to read through and look at chapter 15. Second thing you want to do is take the quiz on chapter 15, open book, open note. You can have it in front of you. I do have it set to 2 attempts. So the higher of the 2 is what you get graded on. And then also watch that video before the next time we get together, because I want to be, you know, when we do our task list and our brainstorming, I want like conversation. I don't want this like looking at me with blank stares because nobody looked at chapter 15 yet. Okay. I don't want that. I want you kind of ready to, you know, to discuss these things. So, so as we go through, you're going to notice as well that these lectures, if you would, are going to be overviews. This is not going to be me redoing gear design. We already did gear design early on in our class. I'm going to be talking about it, revisiting the spreadsheet, reminding us of some things, but then you're going to take the reins and you're going to design the gears for your application. The same thing with the gearbox layout. I'm going to give you some examples of what a good layout looks like, and then it's going to be you putting it together. Shaft design, same thing, bearing design, because again, you've done the details here, and now it's going to be just like, you know, seeing how it affects other things. All right. So many times in any design project, it's a lot about just getting started, getting things on your paper, seeing how it's looking, seeing how it affects other elements down the line, and then maybe going back and redesigning and re-updating accordingly. And that's what you're going to find in here. This is not a linear process. We're going to probably find that many of you, whatever gears you pick out initially, if you're able to keep those after shaft design, you're lucky. Okay, because a lot of times we got to go back and we've got to redesign because now the bores aren't big enough in the gears. So now I've got to make larger gears, and that's not uncommon. All right, but we don't know that until we do our shaft design, and we can't do our shaft design until we do our gear design. So we pick out our gears so we get our forces, right? So so it's going to be a little bit of back and forth, but it's a great experience in kind of up here. You're going to notice that on our task list, we're going to be predicting how much time do we think it's going to take us, for instance, to do our gear design. And then you're going to be putting notes in like, how long did it actually take you to do it? And then you're going to be able to compare those things and kind of see, from the perspective of the front end, but then also the perspective of the back end, how it can be different. Okay. So I just want to kind of give you that overview in a nutshell, but then also assign for you the reading of the chapter, the taking the quiz, and then watching the short video there just to kind of get our minds in that double reduction gearbox, type of atmosphere or mode, if you would, so that we can start then the ground running on Tuesday next week. Okay, so that's really all I wanted to talk about for module 7. So, so if you're still working on shaft design, that's totally fine. Or if you wanted to start, looking here at module 7, you're free to do that. I am going to peek at the calendar so that you can kind of see what we have carved out as far as dates. So today was just kind of our kickoff, brief overview. I have the chapter 15 quiz. I've got it out there for the 19th to be due so that we can be talking about it here on the 20th, the next time we get together. Okay. And then we're going to be spending really the next 2 weeks on the gearbox design, those elements on the inside. Okay. You'll notice that there are a lot of due dates. I don't have those open to you yet, but you're seeing them on your calendar right now. But that's going to be like the gears, the shafts, all the different little elements that in there, they have their own separate. But so it looks like there's a lot there, but it's broken into chunks is what I did. Okay. So any questions? All right. If not, then I will, I'll let you continue working on whatever you are, but then also next time we'll be switching gears, if you would, to do a double reduction gearbox. All right.